Hello everyone, myself Ruchira Tete. I am here with my project partner Kumudini Tope to demonstrate our project water level monitoring system. As we all know, with the conventional water tanks, it gets difficult to monitor the water level as this does not provide any such kind of facility. So they lead to the large amount of water wastage. So we have proposed a system which will help us to monitor the water level in the remotely located tanks to avoid the water wastage. This is the architecture of our system. An ultrasonic sensor, which is SCSR04, will be placed over a tank. It will communicate with the Arduino microcontroller and it will send the water level details to the server, which then it will be transferred to the admin user over the web application. This is the circuit diagram of our project. Ultrasonic sensor is connected to the Arduino controller to know the distance, that is the water level in the tank. A Wi-Fi module is connected to the Arduino so that it will get access to the Wi-Fi network, and a GSM module will enable Arduino to send text messages or make calls. For this project, we have used Arduino IDE. We have designed web pages using PHP. Database is managed using MySQL over SAM server. The hardware components used are Arduino Uno microcontroller and HCSR04 ultrasonic sensor. We have used breadboard and jumper wires for connecting the breadboards and the items with the Arduino header pins. A GSM module in order to send SMS or make a call. Also, we have used ESP8266 Wi-Fi module to give microcontroller access to the Wi-Fi network. Along with this system, we are providing a web application that will make admin user easy to monitor the water levels in the remotely located tanks. So the following slides will walk us through the web application. This is the admin login page. This is the main dashboard of our web application from where user can see the number of available tanks, number of different supporting areas of those tanks. So next section is a tank details where user can track or monitor all the tanks which has water level about 80% and the tanks which are below the 80% will be populated in the same format under tank not filled. With the help of Google Maps, user can locate the tanks on the Google Map. User can also add new tank using the Google Map at any location. And those tank details will then be stored in a database for monitoring. This is a data parser. When we get it, as the sensor sends the data, the parser will get executed and it will give us a data in this format. Once water tank reaches to either a filling capacity or it gets empty, then the GSM module will send a text message to the user saying the tank is filling or the tank is empty and do their respective actions. So, what are the conclusion of this project is, as we are using the IoT, it is the system the system has very less human intervention in locating and monitoring the tank or water storages. Since the information is being processed automatically, that's why there are less chances of human error, and this is a cost effective and feasible solution for monitoring water tanks remotely in wide range of areas like industries, residential, and etc. Now, my partner Kumudini will walk you through the actual demonstration of our project.
Hello everyone, my name is Kumudini and I will demonstrate you our project, which is water level monitoring system. So in our project we have used ultrasonic sensor. This is an ultrasonic sensor, a device that can measure the distance to an object by using sound waves, and it measures distance by sending out a sound wave at a specific frequency and listening for that sound wave to bounce back. Then we have Arduino microcontroller. This is an Arduino Uno microcontroller which consists of both physical programmable circuit board and piece of software. With this I have a GSM module. It is a GSM module. It's a SIM 900 module which has a built-in dual GPS band and GPRS band. It works on a frequency ranging from 900 to 1800 megahertz. With that I have a Wi-Fi module. This is a Wi-Fi ESP8266 chip, and I have used jumper wires and the breadboard for the connections. I have used glass as the tank over here. So this is the Arduino code which will detect the level of the water from the tank using a ultrasonic sensor. So if I compile this code over here and upload it in a Arduino microcontroller, then I'll check the serial monitor to see if all the AT command is working properly or not, and Wi-Fi is getting connected or not. So after that we get the message that Wi-Fi is got connected properly, and you'll get the IP address over here. So if I copy this IP over from here, this is the default Arduino Uno microcontroller IP page which we have copied from the serial monitor. The IP ID over here is 1010, which is the unique tank ID, and the 10 is the level at which the water level is right now in the tank. Right now the glass is empty, that's why it is showing that the level is 10, and you will get an message from the GSM module stating that the tank is empty. So here in this GSM module we have wrote a condition when the distance is 10 or is greater than 10, then this message will get print. So if I refresh the page over here, you can see that I got the level as 10, and I just received a message that the tank is empty, and please fill the or start the water supply. So to parse the data from this Arduino code to the database, I have used a Python where my Python script parse the data. Here you can see that this is my bin tank ID and the level. So if I run my Python script, then you'll get that you'll receive the message that data is getting committed to the database, and after converting the level you are getting this value. We have used a XAMPP server and a MySQL database to store all the data entries. So I have created this three tables over here under my application, which is building, tanks, and users. So building have the building ID and the building name on which building the tank is located. Then I have the tanks table, which have tank ID, the capacity of the tank which is filled, tank address, and for the map we have used latitude and longitude. For login for the admin, I have the table called user, which have two admin, me and my teammate. This is the web application that we have created for our project using PHP. So this is our login page. So if I log in over here, so you'll get to the dashboard. The number of tanks entries in the database is 3. We can show it over here. So there are three tanks in a database. That's why the number of tanks is 3. Supporting area is the location of that particular tank. So if I click on a locate tank in the trail, then it will show me this location. If we go to the dashboard and system action and click on current tank collections, so these are the tank which does not need to be refilled at this moment because the tank capacity field is 10, and these are the tanks where which tank capacity is right now very low, so these need to be refilled ASAP. If we go on a tank details over here, then we can add the tank in our database. So if I say I want to add in the Walmart Supercenter, so I just have to give the tank ID and address and the building ID. If I save it over here, you can see that the query is submitted, okay, and the new record has been successfully created. To check if it is created or not, you can go in a database and in a tank table, you can see that the Walmart with the ID 1013 is created. Over here, you can see the menu and you can log out from here. Again, we can go to the login page and do the login. The tank is not filled right now, and the water level of the corresponding tank ID is getting displayed on the default IP page as a 10. We have parsed the data from Arduino to the database, and we have calibrated the value as per the calculation mentioned by Ruchira. If you want to see if it gets reflect on the application, I'm just refreshing the page and we can see that the tank ID 1010 has a tank capacity 44. And we can see that we just received the message from the GSM module that the tank is about to get empty and start the water supply. You can see now the tank is filled with the water, and the default IP page is showing the value as 2 for the corresponding tank ID, and we can see here the data is getting committed, and on the application also the tank ID 1010 has a tank capacity filled with the water level as 89, and we have just received the message from the GSM module that tank is filling and we have to turn off the water supply. This is how our water level monitoring system works. Thank you so much for listening.